So, before we begin, is everyone in Florida there?
Yep.
We're missing one. He should be here.
Okay, I've been grading the homework. I haven't finished it yet. I received a few from Florida and from last week, and I think most everything from here. Before I begin, some students here came up to me about problem 1 on assignment 3.
Yes, I was unable to access the DCI database from my computer.
And did you have questions on that yourselves in Florida there? I thought it, pardon?
Can you repeat that, sir?
Did you have questions about how to access it and download and put the format the data into a format you can start looking at?
No, my computer, physically couldn't access the web page. It would say error, and then error the number after. Maybe the work of crash version's wrong. Just download the work of crash, but it won't access the website. It won't access the website at all.
Okay, did you do it did you search for it, say on Google, to find the web page, or?
Yes, sir. Let me get a my Google Chrome is.
Okay, because I thought I would spend a few minutes before lecture actually going over some of, in case there are questions. So, does that sound like a plan?
What? UCLA?
So it's University of California at Irvine. So let me share the desktop, and I'll go through some of the process to maybe importing it into Excel. It's not that complicated.
It won't access it. You can download it. It does this on a lot of web pages. I shouldn't be able to access. Do you have a Yes, but I shut it off for the Google Chrome stuff like that. I know, because some of the pages here have a screen unless you have, or not maybe they're not this problem.
We just need to switch rooms.
Pardon?
So we just need to switch rooms. Computers too. Going down the floor room too.
Okay, share.
It's not working.
Go full screen, see if that so you can get the top out. Oh. On the side, left.
Yeah, try that. There you go.
No.
Oh, and you get points for playing the game.
So can everyone in Florida see? Is it full screen? Desktop? Is there anyone?
I
think their mic went off.
Yeah, I think their mic gets turned off whenever we start a session or share at the desktop.
Yeah.
Okay. So what I thought I would do is, let's bring up.
You know how many hours you do it? Honestly.
Why is it cut off there? I can't even read.
Type in the bottom.
What do you?
So I'm bring that up, and then I'm also going to bring up.
Smartboard is working.
Yeah, and now it's interfering with.
You know when he said that?
Don't do anything in that tab. Are you trying to open a new tab?
I was like,
Right.
what did you use?
Hold T. I'm doing it, but it won't work because that Smart Ink is in the way there.
Did you really say that?
So.
That's what I said, stop. He said, stop. That's what you said, stop. No, I said, what did you mean, though?
So it should be pretty straightforward.
Yeah.
I don't know why it would not show up, but maybe we can talk about it with the Florida group after I go through the basic demonstration. It's a whole bunch of different data sets, and if you go to view all data sets right near the top, you'll get a number of different types of data sets, and you can choose a variety. Some of these, as I discovered just a few minutes ago, have a description of the actual attributes, and evidently not all of them actually describe the data sets. I'm just going to choose one at random. And so when you choose that, notice you get a data folder and a data set description. It helps usually to have a data set description which will look something like this. Right, Jeremiah?
Wait, how did you download that?
I didn't download this yet.
Okay. No, I was having trouble downloading the file.
Yeah, that's what I'm going to go over. This is just a description of the data set.
Okay.
And then there's actually the data folder, which will have the actual data sets. And that's what you're going to want to use.
I tried copying that.
And so this tells you it's a hierarchical model that ranks nursery school applications according to some structure. It tells you right under here, under number 7, it gives you the values of the attributes. So parents has nursery, form, children, housing. So you know what the actual columns are related to.
Convenient.
And then class distribution. And so you're going to want to read that as well as look at the actual data set. So the description is going to tell you what's in the actual data set. It'll tell you how many instances. It should tell you. This one has 12,960 separate instances. James.
So you download this, just using the description. Is that, if you wanted to save that, would you have to save that separate from the folder, or is that going to also be included in the folder? Because I see this as documentation.
This is like documentation, right?
Yeah. So is it?
And you can do a copy everything,
And
paste
just
it
go
into
to
a
the
text
folder,
file. So then you have the information to refer to
right next to the data.
right next to the data. My guess is the data is completely separate, and because I looked at some.
Well, I looked down further and it said attribute values.
Oh, here, even in this, even here, I don't know in your example cloud, it didn't have the attribute information farther down. So we'll go back to now look at the data folder, and probably the whole thing is under the nursery.data. So that's got most of your data there. Pardon?
Will Weka open a .data file?
No.
You have to change
Okay.
the text.
So what you're probably going to want to do is I'm going to, you can click on this, and there's the data. Depending, you should be able, I tried right-clicking there, it didn't give me an option to actually download, although it should have.
That's what I was.
Go back, right click, that might be different.
I tried right clicking and it didn't work.
I did option click on the
Save link
Mac.
as, and then
Save
you
a
can
link as,
and you
But
can
that
change
saves
it
the
to a
link.
text.
that
file.
saves the link.
Oh. Duh.
Okay.
Alright then, I don't know.
On my laptop I did option
Control.
So you were able
click,
to
and
download.
that just downloaded it directly to my laptop.
Maybe you just have to copy it in.
But you could do a copy paste.
I tried that and it didn't want to accept it. I don't know if I was doing something wrong.
Did
You
you
can just do
want-
Control A.
Right. Select all.
Yep.
And then Control C. And then you're gonna wanna save it
That's a dot data, right?
in like a notepad,
Yeah.
in as a basic text file, a .txt or a .csv file. That's our ultimate plan there, and
Just, yeah.
There's only so much as
Type in notepad and hit enter.
Oh, yeah.
You gotta click on it.
Keyboard's always faster than moving the
so now we can save that as, say,
A dot data, right?
no, you're not gonna wanna save it as a .data. That's one of the main
What do
things.
you save it as?
So we'll save that as
Oh, you
a
just save it.
.txt file here, or as a CSV file.
Okay.
You basically want to, the part of the goal is if there are any extraneous characters, you want to make sure that those are not included in your file. And that can be an issue, and so that's one of the, so here, encoding probably ANSI there, so let's save that. I'm going to save that as,
Data.text.
what was the name, nursery?
Yeah.
.text. So hopefully that worked, and now we're going to go to downloads, and there it should be as a text document. Just double click, make sure it's all there. Sometimes it'll add extraneous lines, so you want to make sure, and sometimes depending on operating systems, line returns might be handled slightly differently. Those are issues that I can help you with one-on-one because I've had experience dealing with issues like that. So now, maybe you want to incorporate it, you want to start looking at that data. First of all, right now, it should be as a text file. It appeared as though all the attributes were separated using comma. So what we're going to do is no, I don't. I just want a new workbook.
Blank book.
So we're going to I'm not sure, I know pardon?
Are you trying to find the import?
Import. I'm not used to the Windows versions.
I believe it is under file.
But it didn't say import.
Options.
Options.
No.
Maybe go to insert.
That was the other place I was going to look at.
I think Open might have the option to automatically import it if it's not.
Possibly.
Open from the computer. Perhaps.
No. That's just gonna that won't import.
Well,
Yeah,
okay,
well-
now say instead of
Now it
Excel
says
file,
Excel files,
Text.
text files.
nursery.
There it is.
And yours.
Open. Okay, that's good, because notice now we've got an import wizard here. So we've got options. We're going to want to use delimiters. Delimiters are things that separate our different attributes. So in this case, that's what we're going to choose. It appeared as though everything was a comma separated, but it might also be tab separated. Some different sources will use different delimiters. I didn't see that there was an issue with anything else, so I'm going to just import it using those two. And then column, we're just going to finish it. And now, so this is what I wanted to just kind of briefly go over. Everything should be separated in terms of the 9 different attributes, A through I, are now in separate columns in Excel. And now it's much easier to start working with than, say, the text the text file, the .data file. Does that help, Cody?
See.
Was that pretty straightforward?
Yeah.
So we'll go back to the program and see if was that clear in Daytona Beach?
See.
Why is our camera off?
Yeah.
That was pretty clear. Did anyone? So but you weren't able to find the website. Was that the problem, or?
No, my computer physically won't load the website page. It doesn't. For some reason, you use the download page. You just don't select email address.
So it's just your computer?
No, MacBook, sir.
Yeah, MacBook. Maybe if he uses one of the school computers.
Maybe if you get a real computer, Taylor.
No, sir. So, shall we move on to where we left off last time? So, but before we do, I just want to make an announcement. The quiz will be after we finish all of classification section. So today we're going to finish talking about support vector machines. We'll also either today or Friday begin talking about artificial neural networks, and then we'll follow that with what are called ensemble methods, and that should, I'm pretty sure that will then complete the. I think classification is probably the largest module that we're going to work with, and so we'll have our first quiz after we finish the classification.
So,
Yes, Pablo.
The next homework assignment we're gonna have that due Wednesday. And
Yes, I just put the next homework assignment 4, up on the web.
So our quiz will be
On the line.
on Wednesday or Friday.
Let's just see. I just want to finish the classification
Okay.
module, and then we'll have a test covering basically everything up through classification.
Okay.
Will be
So
the quiz.
this next homework assignment is gonna
Wednesday.
Well, it's in the classification.
It's
stuff.
in the. It's on. So it will be on decision trees,
Okay.
and so you'll actually get some hands-on on that.
Okay.
Okay. Is that structure fairly clear to everyone?
It's a new face.
Yes.
Okay. In that case, I will continue on with where we left off. Last time we had started a brief introduction to support vector machines. We're going to get in a little more depth and talk about some of the issues there. So I'll do a review to
That took a while.
start. There we go. So, as I started talking on Monday, today's Wednesday, right? These were invented by Vladimir Vapnik and his co-workers and introduced in 1992. Has a very robust theoretical foundation based on statistical learning theory. We'll go over some of the details today. I mentioned also on Monday that it's had in the past empirically rather good performance and with lots of successful applications. Bioinformatics is one huge area where it's been really successful. And I also mentioned, and maybe we'll later on, I did mention briefly about deep learning neural networks. We're going to actually talk about artificial neural networks beginning probably on Friday. And that's deep learning neural networks are an extension of that line of research. Although deep learning methods apply more generally. So what are support vector machines? So basically, and I'm going to go through some simple descriptions here. I don't know if people have heard of linear regression line of best fit. It's basically based on some principles along those lines. And what we're going to be doing, instead of a line, we're generalizing to higher dimensional spaces. So we're going to be looking at hyperplanes, and I'll give a graphical depiction of this in a few seconds, to separate different classes of data. So, and it's also based on this idea of what's called maximum support, and that's going to be adjusting our plane, or in 2 dimensions, our line, to separate the two classes as much as possible. So the pictures usually speak louder than words. So here's a pictorial description of what I'm looking at. And so you can think of these 2 clusters. You've got the black cluster and the white cluster down there. And we're looking at 3 different hyperplanes here. H1, H2, and H3, right? So H1 is pretty lousy, right? Because it doesn't separate the two clusters very well. In fact, it doesn't separate them at all, right? You can see that. What about H2? H2 is the blue line.
It's like a vertical separation.
It separates the two classes, right? But compare that now to H3, which also separates the two classes. Notice that the distance from H2 to its closest members of either class is quite small. So you've got
But it's equal.
right. But take a look now at the red line, and now I've got a larger separation between the two classes. That's the idea of maximum support. We want to try to make not just separation, but the largest possible separation that we can between the two classes.
And what does that do?
That, well, basically, that gives us more play to work with. And it's also going to allow us later on to adjust, as we adjust the support vector machines to allow for misclassifications. It's going to give us larger options for what's called slack variables. But the main reason is, you can screw up more.
Like a safe.
Right? You're safer. I mean,
Is it as accurate? I mean,
as what?
I don't know. Well, I don't know.
Yeah, I mean, they both H2 and H3 on the training set. So think about it. On the training set, they both do a decent job, right? But there's just not as much separation. So now you're going to do a test. And on your test value, what happens if, so I'll do the screen here. What happens if the test value ends up right here? Well, according to H2, it would belong to the white group, and then according to H3, it would be in the other group. What? The bad boys
The
group.
black group, right?
Right.
The darker shade.
Yeah, see.
I'm telling you, putting
Wait, did it not
Really
go?
weird.
It's perfect.
Okay, did I go too far there?
That's what you put in the direct. Apparently, it's not just my stuff.
the-
Your mouse isn't staying.
Okay, so that's where we were, so we,
Can we just color right?
You should have two people downstairs.
okay. So this is called the maximum margin or maximum support vector. That's where the name support comes from. It becomes what's called a constrained optimization problem. If you've seen, that's probably not something most people have been familiar with unless you've seen some multivariable calculus. In which case you have. Basically, it's going to come down to minimizing some set of weights. Those weights are the description of your line or your hyperplane. I'm going to make this pretty, right down here, notice W, that's a dot product. Your instances are your x values, so you're looking at the x values. And so if you notice, the subject to, this is basically describing your hyperplane. And you're minimizing essentially this quadratic function of weights, which you can kind of relate to the original problem as kind of a cost function. That's your quadratic programming optimization problem. So you're basically getting this parabolic curve of some sort, subject to trying to satisfy being on lines. And you want to minimize that. And for those who have seen some multivariable calculus, you've actually done this before when you looked at Lagrange multipliers. So anybody here? I know, James, you've seen that, Eric. I'm not going to spend a lot of time on that.
Lagrange multipliers is fun. Let's learn about it. Really not.
Well, we're going to come back to that briefly, but we're not going to talk about them in depth. I'm just going to give some description here. So, but before we do that, I want to talk about, so on the example we had, H2 and H3 in particular, that hyperplane, gave complete exact separation, right? But most of the time, the data is not quite that clean cut. Most of the time, you have, the classes intermingle a little bit, as in this picture here.
That's what I was wondering about.
Okay, notice you've got you've got versions of the, for lack of a better word, the white class up here mixed in with the, actually they look like red dots if you look really closely, but
You could have said hollow and solid.
hollow and solid.
The not white class.
You've got the hollow one mixed in with the solids here, and the solid one mixed in with the hollows down below. So how to handle situations like this? So notice, the first description was introduced in 1992, but this is the way things go. You start.
So
These
I
get,
didn't understand what you were talking about.
I'm missing some slides here.
Oh, I get it.
Yeah, it won't go back.
If I submit my name on the app again.
Use the arrows on the keyboard.
I'm doing that.
What?
There should be, here, it just went too far. Okay?
Yeah, it did.
So the original support vector machine introduced in 1992 to solve this misclassification where the classes are mixed there. A new method, an extension of the original method was proposed called the soft margin method. Basically, this is this idea. So if you've ever had any sort of optimization problem, and we teach that in Math 104.
I didn't take that.
But I realize that's linear programming, which is related to quadratic programming. You can introduce these ideas called slack variables, which basically measure the amount of slack between your optimum and how far you can move in different directions. Again, I don't want to go into depth on that, but basically it gives this ability to shift these lines to allow changes in your original cost function up here to account for misclassifications as well as a little more slop, so to speak. The margin, soft margin, so it can wiggle a little bit in a way, if that makes sense. The basic upshot here, rather than going into the details, is we can adjust for those misclassifications and do that again on a problem-specific method in our cost function. The other obvious, did I skip again too far ahead? No. So there should have been another picture here. Okay, so far everything we've looked at has been classifying two different classes. So support vector machines are binary. They classify two particular classes. But also we've been using hyperplanes. What that means is all of our data has to lie basically on one side or another of a hyperplane, and basically a linear function. So the question then becomes, what happens if that's not the case? And so that leads to what's called nonlinear support vector machines. And we're going to introduce what's called the kernel trick. And if you notice, going back here, because we're looking at vectors, we can go back. And here's our hyperplane. It's a dot product between our coefficients, our weights, W, and the values of our attributes, X sub I. That sub I. So we're taking a look at this dot product, and if you look, this is an equation of a line. So in other words, AX plus B, WX plus B in one. That should be Y sub I equals, and basically the idea there then becomes that it's a straight line, and notice their dot product is in this W dot X right there. Okay? So to try to get things nonlinear, we're going to redefine that dot product. And that's through this idea called the kernel trick, which I'm going to demonstrate in a... So here's our normal dot product. If I take two vectors, x and x prime. Everyone here seen dot product?
No, what is it?
Another notation, a couple other notations, and in matrices, if you think of vectors as a column vectors, you can also relate the dot product as as the transpose of that vector times the vector. Because you're, right, because you're going to be going, does that make sense, Pablo? You're giving me a...
Yeah, we got two vectors. Transpose.
Transpose turns it into a row vector, like a 1 by n, and then times an n by 1. So they have to be the same dimension. X and x prime have to be the same dimension. And you're going to be adding across. So I can also represent my dot product as a matrix multiplication of a transpose of the first vector times the second vector, times the second vector. And here's what we're going to do. We're going to redefine our dot product using what's called a kernel function between the two vectors, x and x prime. And the kernel function is going to be something, again, problem specific. What choice are we going to use for the kernel function depends upon what sort of shape our data has, where visualization could be useful there. So, and what we're going to first do to define this is to have a new function phi, which goes from my original attribute space crossed with itself. So it takes my x and my x prime. And what it does is it's now going to transform that into some higher dimensional space. And I should have some pictures here for the radial basis function momentarily, and then see how that actually works.
You can think about projection or rotation.
Yeah, follow. Let the dog borrow your mouse.
So here's an example of maybe some data. Well, that's not very linearly separated.
Yeah.
Right?
Yeah.
Here you've got red and blue.
Okay.
Right? And you want to separate those classes designated by those instances designated red from those designated blue. And notice here this is more circular, which will be really good for what's called the radial basis function. And so I'm going to show, but elliptical, anything with that sort of general shape could be very useful here. But there's a whole bunch of kernel functions that I'll list at the end here as well. But let's proceed with this example. Hopefully. Okay, so the radial basis function can translate that last picture. It projects it as Hong, you heard Hong just mention projection, into some higher dimensional space. And in this example, it's transformed it into this very peak-shaped region. And I've denoted in here a representative possible hyperplane through that straight line that now cuts it. And now, because it's in this higher dimensional space, up above gets labeled as one class, and what's down below can get labeled as another class. And now you can visually see that it could do more circular regions here for the two classes. So that's called the kernel trick. You have this function, and I think, I think I had the function, I don't know where, these slides don't seem to be, the computer's acting up a bit in terms of going through the slides. I think I had the actual equation for the radial basis function. It's also called the Gaussian kernel.
Huh. Okay.
Um,
Makes sense.
Because,
Is it maybe on the next one after this?
no, it's on the previous one. No? I do know our computer is acting up, so. Yeah, there it is. So there's a slide that completely got missed. That transforms a feature space into a higher dimensional feature space. We just saw that. Here's the example of the radial basis function. The function is e, or the exponential, to the negative, typically Euclidean norm, Euclidean metric, our normal everyday square root of x squared, 1 squared plus x2 squared, of x minus x prime. So the distance between the two vectors, squared, summed, squared. But here I'm not taking the square root. I'm taking the square of that distance between x and x prime. And then this is the normalization factor dividing by twice the variance. And basically that picture in one dimension is your normal curve. In 2 dimensions, it's the graph that we just saw. So that in 2 dimensions, it's that picture.
Yeah.
In 2 dimensions, it would look like this picture here. So then we slice it using our hyperplane into the 2 classes. And again, it depends on the problem and what the actual data looks like. But there are many different kernels one could choose. I'm going to just give a partial list here. Linear, polynomial, quadratic, cubic, so forth. The Gaussian or radial basis function, exponential kernels. Again, you want to choose the kernel that's going to best fit your data. Sigmoidal, that's basically your hyperbolic tangent shape, which is very useful. Circular, and we'll see the hyperbolic tangent probably function when we come back to artificial neural networks in a bit. A circular kernel, a spherical kernel, a sine wave type kernel, logarithmic kernels, splines, which are when you start piecing curves together.
We did on Calc 3, right?
I'm not sure Calc 3, we've done it in numerical analysis. Right?
So,
wavelets, which are single individual waves. So that just gives some idea of what one can do with support vector machines.
So with these examples, are x and x prime represent a class of multiple attributes?
Right. Well, x is a vector of attributes.
Right.
X prime would be another vector of those attributes.
Okay. So my question is, how would it would be the same thing with multiple classes, more than 2 classes, x and x prime? So
No. X.
Could you?
What do you mean 2 class? So yeah. X is a vector. I mean, X could be like 9 attributes.
Right.
Okay.
And x prime.
And X prime
would have the same number of attributes.
Would have the same number of attributes.
Okay. So I'm saying, what if we have like an x double prime?
Right.
Yeah. Can we compare more than 2 classes at a time?
I mean, we're not comparing. So that's just how we're dealing with transforming. So first of all, support vector machines are binary.
Okay.
Classified.
So
I don't know if that's what your question
I think that answers my question.
Now you might be able to chain these together to try to do more.
No, that was
right. But yeah, no, there's by themselves they strictly classify between 2 different classifications.
Okay, thank you.
So questions in Florida? Okay, and I'll try to get the homework graded as quickly as I can.